This is Final Review 7 on vectors. So we're looking at the point that starts at P, -1, -2, and goes to Q, 3, 1. To find the component form of PQ, we are going to go the tip minus tail. So we're going to end at 3 minus beginning at -1 and 1 minus a -2. So that would make our vector PQ be 4, 3. And the magnitude then is going to be the square root of 4 squared plus 3 squared. And so that is going to be magnitude or length of 5. A unit vector in the direction of PQ means we're going to take our vector PQ and divide it by its magnitude. That'll give us a vector of length 1 in the direction of PQ. So dividing by the magnitude of 5, we'll get 4/5, 3/5. To then create a vector of length 10, we'll multiply our unit vector, our vector of length 1, by 10, and that will give us 8, 6. The ij form of PQ is just 4i plus 3j. And the direction angle, we are going to take the inverse tangent of the y value over the x value. And I'm going to grab my calculator and go second tangent, 3 divided by 4, and that looks like about 36.9 degrees. And that's in quadrant 1, so that would make sense. Okay? Let U be a force of 40 pounds with a direction angle of 20 degrees. So we're going to be something like there's about 20 degrees, and that's going to be our vector U. And our vector V has a magnitude of 60 and an angle of 80. So it's going to look something like that. And we're going to try to find that direction angle. Let me go this way. We're going to try to find the resultant, rather, right there. So our vector U is going to be in component form. Its magnitude, which we said was 40, times the cosine of 20, 40 sine of 20. And the vector V will be its magnitude 80 times the cosine of 80 and 80 sine of 80. So the resultant, what we get when we add those together, is going to look like 40, let me write that better, 40 cosine of 20 plus 80 cosine of 80 will be the x component, and 40 sine 20 plus 80 sine 80 will be the vertical component. So I'm going to plug that in my calculator, and so we're going to get 40 cosine of 20 plus 80 cosine of 80, and that is going to be 51.480. 51.480. Then we'll go 40 sine of 20 plus 80 sine of 80, and that's going to give us a y component of 92.465. So there's our vector. We want its magnitude. So we are going to take the square root of that 51.408 squared plus 92.465 squared, but I'm going to use the exact values on our calculator. So I'm going to go square root of, and then I'm going to go up and capture that 51.479 blah blah blah, square that, plus go up and capture the 92 point whatever and square that and hit enter. So I've got 105.830, and that's going to be in pounds. That's our magnitude of that force. And the direction angle theta is going to be the inverse tangent of y over x. That's going to be our 92.465 over the 51.480. So second tangent, go up and capture that 92 point whatever, divided by, go up and capture that 51 point whatever, and that looks like 60.9 degrees. 60.9 degrees. All right, there's our magnitude and direction angle. So let's see, a plane leaves Laramie flying at 325 miles per hour on a bearing of 150 degrees. The plane encounters a wind of 25 miles per hour at a bearing of 110. Find the ground speed, direction angle, and bearing of the plane. So that 325 miles an hour at 150, there's 90, 150 is going to take us down here. So this is our airspeed vector. Now that bearing was 150 degrees. Since 90 of it comes down there, that's going to make our direction angle theta be a negative 60 degrees. So the airspeed vector is going to be 325 times the cosine of a negative 60 degrees, comma 325 times the sine of negative 60 degrees. Our wind speed vector, I'm going to change colors for this, I think. So our wind speed vector, let's see, it's got a bearing of 110. So there's 90, and 110 is going to be somewhere in there, and that's going to be our wind speed vector. So it's going to have a direction angle that's going to be that 110 minus 90 is 20, and that's going to be down in quadrant 4. So that will make our wind speed vector be 25 cosine of negative 20 degrees, comma 25 sine of a negative 20 degrees. So that will make then our ground speed vector be the airspeed plus the wind speed. So that's going to get us to 325 cosine of negative 60 plus the 25 cosine of negative 20, and 325 cosine of negative 60 plus 25 sine of a negative 20. So let's see, that is going to give us on our calculator, I got 325 cosine of a negative 60 plus 25 cosine of a negative 20, and that looks like 185.992. And then 325 sine of negative 60 plus 25 sine of negative 20, and that looks like a negative 290.009. So there's our ground speed vector. So its speed is going to be its magnitude. And so we're going to go square root of, I'm going to grab that 185 and square that, plus I'm going to grab that negative 290, and then I'm going to back up and delete the negative sign, and then go back to square that, and I'm looking at 344.526. So 344.526, That's going to be in miles per hour. To get the direction angle, we're going to take the inverse tangent of y over x, so that's going to be that negative 290.009 over the 185.992. So let's see, inverse tangent of the, let's see, the negative 290, I've got that, divided by the 185, and that looks like a negative 57.3 degrees. But we got to think about this. Our vector we saw is positive in quadrant 1 and negative in quadrant, or negative y value. So that's going to put us in quadrant 4. So that's exactly what we want. That is a quadrant 4 angle. The bearing is going to be 180 plus the 57.3 degrees. So that's going to make our bearing be 237.3 degrees. So there we have our speed, our direction angle, and our bearing. Okay, now we're going to do a crane problem. So we can see that I'm going to call this vector 1 and this vector 2. So those are going to be force vectors. The tension is the force in those cables. And our vector, I'm going to say the magnitude of vector 1, I'm going to call M1, and the magnitude of vector 2, I'm going to call M2. So the component form of vector 1 is going to be its magnitude, which we don't know, times the cosine of, and now if this is 28 degrees, then our direction angle for vector v1 is going to be 180 minus the 28. So what is that, 152, I believe? So that's going to be our direction angle for our vector 1. And so that will make its components be cosine, M1 cosine 152 and M, whoops, that should be M1. I wrote M2. It should be M1 sine of 152. And vector 2 in component form is going to be M2 cosine of 33 and M2 sine of 33. And our weight vector is going to be 0 and then a negative 12,000 because that's all going down. We know the sum of our horizontal components is going to be 0, M1 cosine of 152 plus M2 cosine of 33 is going to be 0. In a similar fashion, our vertical components are going to be 0, M1 sine 152 plus M2 sine of 33, and then minus the 12,000, which I'm going to add to the other side to be equal to 12,000. So in the first equation, I'm going to solve for M1. So we are going to subtract the M2 cosine 33 to the other side, and then we will divide by the cosine of 152, and so we have that M1 is going to be a negative M2 cosine of 33 divided by cosine of 152, and we're going to plug that in for M1 in the second equation. So that's going to look like negative M2 cosine 33 over cosine 152 times the sine of 152 plus M2 sine of 33 is equal to 12,000. We can factor the M2 out. We can recognize the sine 152 over cosine 52 as a tangent of 152 to simplify our keystrokes. And then that's going to be plus a sine 33. That's equal to 12,000. I'm going to scroll up a little bit to give myself some more room. So we're going to get M2 is going to be 12,000 over a negative cosine of 33 times the tangent of 152 plus the sine of 33. That's all in our denominator. So on the calculator, I'm going to go 12,000 divided by, and then a parentheses, negative cosine of 33 and the cosine times the tangent of 152, and then a plus sign of 33 and the sign, another parentheses to end the denominator, and I'm getting 12,114.261. That's going to be in pounds of force for our M2. I'm just going to call that M2 right here. And then we're going to take that and plug it in over there and get that M1 is going to be a negative. I'm going to capture that 12,000 whatever times the cosine of 33 and the cosine divided by cosine of 152, and that looks like 11,506.769 pounds of force. So there's our M1 and M2. Okay, very good.